Dr. Chelsea Juarez, who, oddly enough, I met on not until the first time tonight, but I've known of her for a while because she went to school with a fellow faculty member, Dr. Deborah Bolter, who said, there's this really cool video you need to watch. And it was a little interview of you talking about doing migrant isotopes.
Yeah.
And I've shown it in my class, at least until I got pulled off the air, so you have to get me hooked up with that again. And it's an amazing story, and I've always wanted to share that with my students, and I'm so excited to bring her here tonight. So let me give you a little bit of the formal introduction then. Chelsea Juarez is an associate professor of anthropology and director of the Fresno State Forensic Anthropology. Well, I don't have a mic, so I'll yell louder. How's that?
You want to stand by me?
On her.
You can stand by me.
All right, I'll stand by you. All right. At California State University, Fresno. She's also director of the Central California, she has a lot of titles, Missing and Unidentified Deceased Persons Cold Case Initiative, a 19-county initiative to identify the deceased and unidentified in rural California. Her research interests focus on isotopic investigations of provenance and diet, with a special focus on the Latino diaspora and the U.S.-Mexico border through time. In addition, Juarez has researched and written about child abuse, intimate partner violence, migration, and provenance in a forensic context, and case accuracy trends in forensic anthropology. She's the author of a comprehensive textbook in forensic anthropology that we use in our classes, and she holds a doctorate from the University of California, Santa Cruz in biological anthropology with a specialization in forensic anthropology and the Latino diaspora. One of the things, though, that's not on here is that she's a local girl. So I'd like to know how many of you are connected with Chelsea here tonight. Woo! Look at that. So grew up across on the west side and is now coming back to meet with us. So
yeah.
Welcome, Chelsea Juarez.
Thank you. Thank you so much. Yes. So can you all hear me? Yeah. Yeah? Okay, great. Super. Thank you for the thumbs up. I like that. This is going to be great because we're going to have an interactive time, and I can already tell that thumbs up back there is going to be Mr. Participation. So I'm excited about you. I'm very excited. So we don't know each other, and usually I wait to ask people for favors, but I'm going to just put it out there. Let's see if this can work. My mom is here, and her birthday is tomorrow. So I was wondering if you would help me sing happy birthday to my mom. Yeah? Would you guys do it for me? Okay, awesome. Ready? 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear mom. Happy birthday to you. Yeah. Before I got here, I was at dinner with some of the fantastic students from MJC and Susan and some of the faculty here, and I relayed a story that when I was 16 years old, I go to the mall here in Modesto with my mom, and she would make me hold her hand. And I'd be like, I'm not holding your hand. And she would be like, if you don't hold my hand, I'm going to bark like a dog. Loud. So this is all of us together payback for that time when you did that to me. Yeah. Okay, so I'm so glad to see you all here tonight. I already had a great time with the students that I met. I want to give you a warning. I am going to be showing human remains in this talk. I want to let you know that if at any point in this talk you feel triggered by anything that you see up here, please feel free to kind of get up, stretch your legs, walk out if you need to. The photographs that are in here are not gratuitous, but we don't really know what is going to trigger someone. So if you feel like you're seeing something that's making you really uncomfortable, don't worry about my feelings. Just feel free to get up and move away if you feel like you need to do that. Okay? I also want to tell you that I'm very conscientious about the use of human remains in my talks. Everything here has been with consent. So I work directly with the counties that I serve, and anything that I show you, I have consent to show you. So I am not showing you something that nobody knows that I'm using. Okay? So I just want to share that with you before we start. So I like to quantify the problem of the murdered and the missing for folks. And I like to start with this because those of us who work cold cases or those of us who work with deceased unidentified remains, it's really easy to start to feel overwhelmed. And I think there's a lot of you in here who might be interested about forensic science in some way. According to the most recent data that we have from the National Crime Information Center, which is run by the FBI, there are over 97,000, which is probably an underestimate because not all of our rural counties report, missing persons in the US right now. Now, not every missing person is a deceased person. Sometimes missing people are just missing, and then they become found again, alive, right? In terms of deceased, unidentified remains, we have over 8,700 known cases of deceased unidentified remains, and that is a far undercount because our rural counties, like the counties that I serve in the Central California area, don't have the manpower to report all of their missing unidentified. And a lot of these people have been buried. So when you work cold cases or when you work with unidentified remains, sometimes the problem gets very overwhelming. And one of the things that we have done at Fresno State to try to deal with this, to try to answer to it or speak to it, was to create the Central California Missing and Unidentified Deceased Persons Cold Case Initiative. We work with our Central California counties to exhume and reanalyze deceased, unidentified Jane and John Does in all of the cemeteries of the Central Valley. We started small, we started with Madera County, but we serve every single county in the state of California that is in the Central Valley, 19 counties in total. Our lab does regular casework as well. So when I say regular casework, I mean we have a fresh murder that just happened a week ago, and for a variety of reasons, law enforcement or the medical examiner feels like that particular case needs forensic anthropology. And so our lab will serve them. So this is an addition to the regular casework that we do. I am going to share with you tonight a case that came from this project. I'm going to share two cases with you. One that came from this project that we identified last year, and an additional one, just to kind of give you a sense of what these cases are like and what it takes to be able to identify people in this context. So for the cases that we serve from this project, we do everything from ground zero. We actually go, I myself, this is a picture of me right here in a grave. We go out, we do the exhumation. Once we exhume, the body comes to the lab at Fresno State. We do all of the forensic anthropology on that person, so sex, age, ancestry, stature analysis, trauma analysis, a full workup. Lots of these people were murdered prior to DNA analysis, so we submit DNA to the California DOJ lab. That DNA information goes to CODIS. We try to see if we get any hits via CODIS. CODIS has two sides. CODIS is the DNA database that's run by the FBI. It has an offender side, and it has a family reference sample side. So any sample that we send into CODIS will be run against both sides to see if we get any hits. If we don't get any identifications off of that and off of the forensic anthropology, then we'll take additional steps. We'll do things like computerized facial reconstruction from the skull, where we can actually take a scan of the skull and put a face back on this person. We will do things like forensic genetic genealogy. We will also look at where was this person born? Where were they the last 5 years of their life? The last year of their life? And we will track them and see if we can use that kind of information to help identify them. This can be a years-long process, and it can be very, very expensive. Forensic genetic genealogy, which I'll talk a little bit about later, costs about $9,000 a case. And we do this work completely on grants. So we don't charge the counties that we work with to do the cold case work. right? And they have volunteers, so deputies volunteer their time to allow us to exhume these cases. So this kind of work is completely volunteer. I get paid for the regular cases that I do, and when I go to court, I make $450 an hour. But I do this work for free because otherwise it would never get done, right? And everybody deserves to be identified. So, before I go into the cold cases, I want to share a little bit with you about our lab at Fresno State. Our lab is one of 2 labs in the country that runs primarily with undergraduate interns. There is only one other lab in the entire United States where undergraduate students get the opportunity to have exposure to real forensic casework. And the other one is in North Carolina. We have a huge caseload in our lab, up to 90 cases a year. I just did an exhumation on Tuesday. We got 4 cases from that exhumation, and prior to that we had 7 fresh cases from Fresno County. We have a lot of cases. Our lab is state of the art. We have a full X-ray suite. We have every single kind of digitizer that is available on the market. We have a robotic arm scanner. We have a microscribe. We have every single tool that you need to do forensic anthropology work. Our students get trained how to do everything from ground zero. How to take a case in, how to conduct all of the analysis, how to take a case out. They learn all about chain of custody. I take 6 interns a year, and the first thing that you have to do is get an A in my human osteology class. That's why we usually only have 3 or 4 interns. It's the hardest class. I mean, I think it's the hardest class at Fresno State. Some of the engineering people might say no, but I think it's pretty dang hard. So I'm just laying that out there in case any of you brave souls want to come and hang out with me at Fresno State. I'd love to see you. I'd love to have you there. If you're interested in visiting, I put my email at the very end of this talk, and I'd love to have you come visit us. We have a great lab. We want you to come. We love all the students from our local junior colleges, and I'm totally excited for you to come and visit and see what we do. Okay, so let's talk about what forensic anthropologists do. Then I'm going to talk to you a little bit about some of the research that I do that helps inform my casework, and then we're going to talk about some cases, okay? So, forensic anthropologists are like medical examiners, but we focus on the hard tissues of the body: bones, teeth, hair, fingernails. Analysis of these tissues helps us to estimate things like sex, age, stature, ancestry, okay, from a decedent's remains. We are expert witnesses. We go to court. We testify. We work all kinds of research. Some of us are professors. Some of us work for the government. Some of us work in medical examiner's office. Some of us work for the FBI. In addition to sex, age, ancestry, and stature, which we call the biological profile, we also do trauma analysis, disease analysis, and the postmortem interval. And some of us have research specializations in addition to that. I do isotopic analysis and the analysis of thermally altered remains. Okay, so I specialize in wildfires, bodies burned by wildfire. Now, let's talk about some of these other things besides the biological profile. Can everybody see this skull over here? So this white stuff on this skull is called adipocere, and also might be known as grave wax, if you've ever read about that before. And this is what happens when bodies decompose in an aqueous environment, so exposed to cold water. Your fat on your body turns to sort of this hard, waxy substance, and this is great when you find this as a forensic anthropologist because it protects tissue. We have pulled bodies out of the Bay Area, right underneath the Golden Gate Bridge, that people have committed suicide 20 years ago. And their tattoos were still visible because of adipocere, protecting the tissue. It's a pretty incredible thing that can happen. You can clearly see eyebrows and eyelashes, and everything is protected. Sometimes the faces are so well protected you can identify off of skin bodies that have been dead more than a decade. So it's a pretty incredible thing. Up here at the top, we have a skull. So this is a representation of trauma. This is a skull that has blunt force trauma to it. We're going to talk more about trauma in a second. But one of the key ways of identifying blunt force trauma is that the soft tissue always shows less damage than what's underneath. So in a case like this one here, where the skull is completely crushed and there's comminuted fractures going all over the place, we might see a little bit of adhesion or some cuts on the skull, and then it's when you resect that tissue that you realize, oh no, the skull is completely crushed. So that's indicative of blunt force trauma. And then down here, do I have any takers for this? I'll give you a hint. It's disease. Any takers?
Cancer?
I like that, brother. No, it's not cancer, but that was a good one. How about thumbs up in the back? You got anything for me?
Some sort of degenerative bone disease?
It's definitely a degenerative bone disease. No takers? Oh, don't raise your hand, honey. Just yell it out. Say it louder. No, I like that though. No. Tertiary syphilis. I put this in there for the young people because you need to wear condoms. Syphilis is on the rise. Okay? This is your sex ed right here. It's a double lecture. It's a double lecture. Sex ed is out there. Fresno County has the highest rate of syphilis infection among newborns in the entire U.S. Okay? So wrap it up. Wrap it up. All right. I'm looking out for you. You know I'm looking out for you. Okay. So now you know what we do. We do the biological profile, sex, age, ancestry, stature, right? We do trauma, we do disease, we do the postmortem interval, and some of us have specializations like DNA and isotopes. But the thing that I do almost every day is I get text messages on my phone from law enforcement of a bone. Dr. Juarez, is this human, yes or no? So now I'm going to give you all the opportunity. You're going to get to raise your hand and vote for one of these choices, okay? One of these hands is human, one of these hands is not. And I'm going to give you a little minute here, and then every single person is going to raise their hand because I'm watching you, right? Okay. That's right. Stress. Look at, point, talk to your neighbor. You need this right now because I'm watching all of you and I'm going to remember it. I'm remembering everything that goes on. Yes. Hey, I'm going to ask you. Okay, are we ready? We got some riled up people up here in the front who are raising their hands and shouting out answers. Okay, this is how we're going to do it. Ready? Watch. Who votes that the hand on the left, this brown hand right here, is human? Raise it up. Yes, that's right. I like you. You just stand up if you feel the spirit is calling you to do that. Okay, good. All right, super. Okay, now, who votes that the hand on the right is the human hand? Raise it up. Did you vote? Did you vote?
The one on the right looks like a orange.
Hey, you only can vote. We can have a conversation about it. One on the right, who is voting? People right here in the second row need to commit. Okay, it's the hand on the right. This hand right here. This is the human hand. What do we think the other hand is? What do we think the other hand is? Who said it? Bear. That's right. Absolutely. You look like you might have been cheating though, because you look like maybe you've seen a bear paw before.
Dr. Martin, zoology.
Dr. Martin knew what it was right away. Let's give him a hand. Yes, it is a bear paw. Dr. Martin, everybody needs to take his zoology class. Yes. All right. So, let's talk about how we know. Bears are quadrupedal. They walk on 4 limbs. Okay? So, this area right here, that's the wrist. If you're quadrupedal, that means that your limb in the front is weight bearing. So, the wrist needs to be bigger. Okay? Here's the wrist of the bear. Here's the wrist of the human. Big size difference there. for structural stability. Okay? Lots of other differences. One of the things that gets a lot of people is, they're like, well, Dr. Warris, the fingertips were cut off. Yeah, because people kill bears for their claws and their gallbladders and all manner of crazy stuff. So that's what was going on here. Do not be fooled. Okay? So if you took my, what was that?
I'm about to say, it kind of reminds me of a burnt hand. Since I seen it in the movie RoboCop, they showed me the guy gets burned.
Yeah, I like that. I have lots of pictures of burnt hands. I didn't put any of them in here. I'm sorry. I don't mean to disappoint you, but that's definitely a conversation that we could have later. Okay, so you need a forensic anthropologist for situations like that, right? I get these texts on my phone. Dr. Warris, what is this? It's not human, don't worry. Oh, it's human, you need to worry, right? You need to call me, I need to come out there, and we need to deal with this. Okay, so what kind of trauma do forensic anthropologists see? What kind of trauma do we deal with? Well, there are some major categories of trauma that we see consistently. This one over here on the left, this is projectile trauma. We don't say gunshot trauma anymore, okay? This is kind of the way that forensic anthropology has changed. It's projectile trauma now. And technically that's because there are lots of other things besides bullets that can cause similar injuries to people. Defects is what we call them. For example, there was a prison riot a number of years ago at San Quentin, and one of the prisoners got shot with a tear gas canister. Not a bullet, a projectile. So now the ABFA has changed it, and we use the term projectile. This is an exit wound for a gunshot, and we know that because what happens is that as a bullet punctures bone, it deforms, as long as it's not fully jacketed, okay? And so as it deforms, it becomes like a pancake as it goes through all the tissues. And so by the time it exits, it's sort of this big flattened pancake, and so it blows out a big bevel out here, and that's what we're looking at. The next thing that we have is sharp force trauma. This is a radius, and this is a result of a disarticulation event. That's a fancy term for you killed someone and now you're trying to cut them up. Okay? Now, we love this as forensic anthropologists because it tells us a lot about the perpetrator. What do you think I can tell about this perpetrator? Yeah, we can tell something about the tool. Excellent, I like that. Yes, it was intentional because they're trying to cut them up, right? So they're trying to cover their crime.
You can see those little marks, right?
Yes, exactly. And look how many of them there are. Look at this. There's 1, 2, 3, 4, 5. Right? That's right. So we have what we call hesitation marks. These are called hesitation marks. And we love that. But I can also tell something else really personal about this person.
He hasn't done it all.
He hasn't got it off, that's right. But he also doesn't have anatomical knowledge, or she. Let's be equal opportunity here. Let's be equal opportunity. Why doesn't this person have anatomical knowledge? They didn't cut at the joint. Anybody who would have taken Dr. J's class would have not embarrassed themselves in this manner, okay? They would have never done this here. That's would have never happened, right? This person came along and they were like, holy moly, I've killed so-and-so, and now I need to cut at the smallest place instead of removing the hand in a responsible manner, okay? Not what happened here, right? All right, so what else do we have? Over here we have blunt force trauma. And then down at the bottom, we've got some flames because we have fire. None of these things, I don't want to suggest that any of these types of trauma happen in an individual way. We see all kinds of cases where there's overlapping in all kinds of trauma, especially with fire. And so people commit crimes and they think, let me just be very clear about this. They believe that they are going to burn the person up. They're going to cremate this. No, friends, you're not. Okay? It is very difficult. You have to be committed, okay, to cremate a body to ash. And I have yet to meet the perpetrator who is that committed, okay? It is no small thing. Let me just explain. In order for a crematorium that burns at 1800 degrees to cremate a body, it takes 3 hours. at 1800 degrees. For you and I to generate 1800 degrees, we would have to go to the tire plant in Tracy and rob them blind. And who's gonna see? The police, because it's gonna be a giant fire. The fire department is gonna come. You're not gonna cremate anybody, okay? So it's a lot harder than people think to do this kind of stuff. And that's the reason why a good forensic anthropologist can always tell what is going on with burned remains. All right, so one of the other things that's really, really important when you testify in court is not just what kind of trauma that you have, but when did the trauma happen? Did the trauma happen before the person died? Thus that, well before death, so that the person could actually heal, the body could heal from this and respond to it. And that's what we're looking at here on the left, okay? This is a long bone, this is a femur, and we can all see that there's this weird sort of basket appearance to it, to this bony kind of scab here. And just like our skin gets a scab, our bone also gets a scab. And they look actually pretty similar, like a basket weave almost. And just like our skin heals, our bone will also heal. It may not look exactly the same, but it kind of smooths out. So you can tell that something happened there, but the external structure smooths out. So you can see in this particular person, they died before that smoothing process could happen. So the basket weave is still there, this irregular appearance. If we look in the middle, this is a skull that has peri-mortem trauma. So this is blunt force trauma that happened at or around the time of death. So there's no evidence of healing, because evidence of healing is what we expect for ante-mortem. Peri-mortem is no evidence of healing, but it's more than that. When we look at the fracture itself, we need to see evidence that the bone is breaking, from an engineering perspective, that the bone is breaking like it would in life. So if you were alive and this happened, we need to see that kind of response from the bone. And that's exactly what we're seeing here. Let me explain. Let's look right here where the cheekbone is, and we can see that the cheekbone is broken and it's missing this middle part. We can also see that as the blow came on the cheekbone, not only did it hit the cheekbone area, but it also kind of hit this area over here by the external auditory meatus, or the ear hole, okay? And so we've got a couple of fractures that are coming off of this area. We've got this one right here. We've got this one right here. We've got one that's coming up this way. Now let's look and see what happens with this one, because this is really important. This one comes up and it bounces over the squamosal suture. And that is indicative of peri-mortem trauma. The blow was so hard that the body did not have time to respond with plastic deformation, and the force of the blow bounced over the suture, which is open in most people, and so it couldn't even dissipate the force. It was so fast. So we look here and we say, okay, peri-mortem trauma. And then finally over here, we've got post-mortem trauma, trauma that happened way after death was over, okay? So we don't see any healing, but not only do we not see healing, we also do not see the bone reacting like it would in life. And you might say, well, how do you know? Let's look at the color difference. Can we all agree that this skull is brown? Yeah. Because what's happened, right, is that when you decompose, your cells lyse, and when they open, they release all of this liquid. And this person was buried in a shallow grave in the dirt. So when that liquid happened, it mixed with the dirt that was around it and became mud. And it stained that person's body brown. And then when we went with the backhoe to dig for this body, we were digging 1 inch at a time, and the backhoe tooth went too deep and punctured this hole on the top of the head. And now when that happened, it opened up this white border, exposing this white diplo, which is the material in between the two layers of compact bone of the skull. It's white because that damage happened after decomposition was done. So there's a color difference between those two surfaces, and we could clearly see that it's post-mortem. Okay, so we got to get along here. I only have a little bit more time. Now we know what we do. When do you call us? When do you need a forensic anthropologist? Well, you need a forensic anthropologist when I'm going to put this in quotes because it never works, eyewitness comes to you and says, I saw so-and-so get murdered. I wasn't involved in it, but I saw so-and-so, and they're buried right over here. And I'm putting it in quotes because I have been a forensic anthropologist for over 20 years, and so-and-so never led me to a dead person, okay? So, you need a forensic anthropologist when you're doing a clandestine recovery. You got a hidden body somewhere, you need to find that body, you need a forensic anthropologist for that. We specialize in clandestine recovery, okay? Not only do we find dead people, or I guess, see dead people, we also recover them very well. So the recoveries are complete, right? Because we're specialists in bone. So we've got a team here working on an excavation, and this is a little screen, and we're screening the dirt to do a complete recovery. We're gonna pick up every single finger bone, the coccyx, all those little pieces, the hyoid, everything. We're gonna get all of it. You need a forensic anthropologist when you have complex trauma. Now, some people think that forensic anthropologists get skeletons in the lab. No, my friends, we don't. We get fully flesh bodies. Some of them are as fresh as you and I look right now, fully with hair. They got their fake nails on. They got their big old eyelashes going. It's the whole gamut, okay? Everything. If a medical examiner thinks that a body has complex trauma or there might be child abuse, that's when you need a forensic anthropologist. Complex trauma, what does it mean? Multiple types or multiple time periods. Let's look at this guy right here. So we have a guy right here. We can see that there's a metal plate on the radius. We could see that we've got some surgical intervention up here. So we've got a ante-mortem injury. He then proceeded to get into another fight after being released from the hospital. So we've got perimortem blunt force trauma to the forehead. So complex, right? Because we're dealing with multiple time periods. Or over here, this bone that we've already seen, this bone has an oblique fracture. This is a tibia. Fire cannot cause an oblique fracture. An oblique fracture is a fracture on the diagonal, okay? So something that's on the diagonal. Fire cannot cause that. Only blunt force trauma can. So we had somebody who did blunt force trauma, and then they tried to burn someone, right? So that's complex. You might need a forensic anthropologist if you only have one bone. And you're like, what am I gonna do with this one bone that I have? How am I gonna tell anything about this decedent from this one bone? Or maybe you have a bunch of fragments. And you're like, what am I gonna do? This, by the way, is what cremains used to look like before they started using the new technique that actually turns things into powder. So back in the 80s, you used to get a sack of cremains. When somebody got cremated, it looked like this. And then the industry kind of discovered that people started getting upset when they'd open the bag and they're like pulling out a big old shard and they're like, what is this? So they were like, America is not ready for it. They need powder. So now they have a big giant martini shaker, they put you in there and they go, brrr, and you get powder. But this is what you look like when you come out before they do that, okay? It could also be a situation where you have somebody who's really decomposed. Medical examiners specialize in soft tissue. They don't do hard stuff. So if there's no soft stuff left, they need our help, okay? Or you have mass disaster. A couple years ago in Fresno and Madera County, we had the Creek Fire. You guys all remember how that really badass team came in, the National Guard, and they rescued over 200 people from the boat dock on Mammoth Pool. Okay, so then after that was done, and they rescued all those people, there was Dr. Juarez that had to go in there and search 100 cars, several different structures that had burned down, all these tents that people ran away from looking for dead people. Okay, so we also come and we do mass disaster response. This is me. Right here, very sad because I feel like I can't breathe at this point. I had a respirator on, but it was very terrible to do that work. Okay, so now we know what we do, now we know how we come there. Let's talk a little bit about research, some of the research that I do and how it informs casework, and then we're gonna get into the cases themselves. So Susan already told you some of the work that I do. This is from a recent publication, this picture here on the left. we created a classification system for thermally altered human remains so that forensic anthropologists can communicate to each other about how badly burned human remains are. And it turns out that this is really important because human remains, when they burn, they have a specific pattern of changes that happen. And if that pattern doesn't occur, then it means that the remains were sequestered in some way. Maybe you were wrapped up in a carpet. Maybe you had your hands tied behind your back. Maybe you had a big cut down your abdomen. Maybe something was different about your soft tissue or your positionality that did not allow you to burn like you would if you were just laying on your back or on your front. And so when we see differences in those changes, then we know something wasn't right when the body started burning. I also do a lot of provenience analysis. What does this mean? It means I use bone chemistry from fingernails, hair, teeth, and bones, and I can track you across planet Earth. I can say where you were born. I can say where you've been the last 10 or 15 years of your life. If I have hair, I can say where you've been the last couple months of your life. And this becomes really important when we have a dead person who we cannot ID, and we don't even know if they're from the place where they were found. So the most important question that we answer with isotope chemistry is, are you from the place where you were found, yes or no? Okay, and this helps direct our investigation. Okay, so let's talk a little bit about how that works. Who is really excited to see the periodic table? Raise your hand. We got two people who are probably lying in the back. Okay. Yes. So the rest of you were like, oh my God, she's showing the table. I'm feeling really upset. Okay. So what are isotopes and how do they work? Okay, so we've got the table, right? We've got the elements. And the only thing that isotopes are the versions of the elements that have a different weight. That's it. They weigh a different amount. They have a different mass, okay? And some of these isotopes are radiogenic, which means they go through a decay, and some of them are stable. The ones that I use are stable. No glowing going on here, okay? Now, the most common isotopes that are used for forensic proveniencing are our friend hydrogen, strontium, carbon, nitrogen, oxygen, sulfur, and lead. It turns out that your body is a storybook, okay? If we take multiple isotopes and we analyze them and we take multiple tissues, we can tell a story about you. If I want to know where you're born, I need a tooth for that, but not every tooth is the same. I need a tooth that records isotopes during the period of 0 to 3. So there's only certain teeth that can do this work. It's got to be your central incisors, your permanent central incisors, or your first permanent molars. Other teeth record other different time periods. Okay? If I want to talk about where you've been for the last 10 to 15 years, I need a femur for that. If I want to know where you've been the last 5 years, I need a rib for that. And that's because of the difference in bone turnover rate between these two different kinds of bones. If I want to be able to track you in real time, almost in real time, weeks to months, I need a hair. And the longer your hair is, the more information I can get from you. And let me just say, it doesn't have to be a hair from your head. You know what I'm talking about. Arm hair. No, just kidding. Okay, so sometimes we're limited by the types of isotopes we can get out of the tissues, but for the most part, the ones that we use for proveniencing, we can get out of all of these tissues. Okay, so how do we kind of start a process like this? Well, the first thing we got to do is we got to look at our decedent, and we got to see, well, what kind of tissues do I have to work with, right? Do I have a hair? Do I have a tooth? Do I have a rib? Because bodies are all different, and sometimes they're in a state of decay, and we don't have everything, right? So we can't always do the full picture. But what we can do is assess what we have, and then what do we want to know? Is the only question that we want to know, is this person from here, yes or no? And if that's the only question, we just pluck a tooth and we go from there. But if we need more info, because we have a feeling that this person might be an international case, then we need more tissues for that. And we need to lay those isotopes and those tissues on top of each other, just like a storybook, to tell a story about this person. One of the things that I specialize in is estimating drinking water from human tissues. What was the water that you had to drink in order to make the hair that's on your head from an isotopic perspective? That is because the way that isotopes get incorporated into our bodies is through food and water. If we're talking about oxygen isotopes, they primarily get incorporated into our bodies through drinking water. Drinking water oxygen varies as we move away from the coast, and it has to do with the water cycle. Heavier isotopes get removed as we move away, and then we have lighter and lighter ones that are left over, and then we get differences in values from these tissues. Some isotopes, like oxygen, are also geologically specific, like strontium. But those get incorporated into our bodies through food. So it turns out that strontium comes from bedrock, up through plants, and then into our bodies. Strontium values are not unique, like DNA or a fingerprint, but they are different between areas, just like oxygen. Not unique, but it is and can be different. This is an example of an oxygen isotope drinking map of the United States. And you can see, just like I said, they're not unique. We can see that in California, we've got some of the similar values that we see over here on the East Coast. This is the reason why we need to lay over multiple isotopes, because these values repeat themselves. This is an example of a human hair map. So the value of human hairs across the entire United States for hydrogen isotopes and oxygen isotopes. Okay? So there's a relationship between these values in your hair and the drinking water, and we can use mathematical equations to estimate them. So all we have to do is just pluck a hair from your head, and we can tell what drinking water made the hair. If the hair is long, I can cut it into weeks. And I could say, you drank this value here, here, here. Oh, look, it went up. Now it's here, here, here. Now I can go down. So I can track you over the length of the hair. Okay? All right, let's talk about the case study. Not all cases are the same. Not all involvement in cases are the same. Sometimes I do a case from ground zero to finish, to identification of the person. Sometimes I get called in to do a part of the case. That's what happened here. This is a case from Illinois. This is a case from Champaign County, Illinois. In 1994, Champaign County Sheriff found a decedent in a cornfield. It was a young woman who was badly decomposed, who had been beaten to death. And her face was pretty much decomposed to the point where they couldn't identify her on soft tissue. The medical examiner had a forensic anthropologist at the time, and this forensic anthropologist estimated her to be quite young, 16 to 18. They were analyzing the trauma, pretty extensive, not only cranial but also postcranial trauma. Pretty much every bone in her body was broken. No missing persons report was ever filed, and the case went cold. In 2016, Champaign County got a new forensic anthropologist, a friend and colleague of mine who I went to grad school with. And she decided that she was going to exhume this woman, and she was going to try to identify her. So she redid the forensic anthropology analysis on her, and she called me up and asked me if I would do isotope analysis. And I said, yeah. Send me a tooth, send me a rib, send me a femur. If you have hair, send me hair, and I'll do it. So we revisited the case in 2019. Let's walk through this data. Welcome to the difficult world of isotopes. Okay, let's look. Here's the femur data, here's the rib data, here's the enamel data on the bottom. Let's first look at the oxygen isotope data. For the femur, which is the last 10 to 15 years of life, we've got 26.6 per mil. Let's go down to the rib. This is the last 5 years of life, 27.1 per mil. Now, anybody in here who is a statistician or anybody who does mechanistic analysis of any kind is going to look at that and say they're the same number. And if you weren't an isotope person, you would be right. This is the kind of minutia we're talking about here. These are actually different, slightly different numbers. Let's go down to the enamel. Remember, this is birthplace, okay? 27.1. So let's look and see a first order interpretation. The enamel and the rib, very similar. The femur, different. This could mean a person was born in a place, then in the middle of their life they went away from that place, and either then they moved back to that place or they moved to another place that was similar isotopically to the first place. Okay, first order interpretation. Let's look at the strontium. Strontium, geologically specific, is going to record information about a place. We're having to look in the fourth significant figure for difference. This is what I'm talking about. Basically, I'm an accountant, okay? A bone accountant. That is what I'm talking about here. We've got 0.70934 for the femur. We go down to the rib, 0.70946. Okay, we go down to the tooth, 0.70942. If you were anybody else, you'd be like, this is the same number, but not for me. And the best part of it is it's reflecting the other pattern that I saw. We've got a difference, we've got a fluctuation, some kind of a migration. Carbon is going to give us dietary information, not necessarily useful for provenience analysis, but it's the other side of the coin for oxygen, so we basically get that data spit out at us when we run oxygen isotopes from appetite. Let's look at the map. This is me mapping birthplace and where this person was the last 5 years of their life. Any place where you see red, that is the oxygen isotopes that are consistent where this person could have been from. Any place where you see green, this is where this person could have been the last 5 years of their life. Let's do a close-up because that's really hard to see. The first question that we want to know, what is the first question that we want to know?
Where they're born.
That's right. Are they isotopically consistent where the body was found, yes or no? This is the power. This is the power of isotopes right here. She was found right here. The yellow, tiny little yellow stuff, that is going to be the strontium of the last 5 years of life. And this little tiny turquoise stuff, that's going to be the strontium consistent with birthplace. Any place where we have an overlay like that, we need to look at it. Okay? So the answer to the question is, yeah, she is consistent with where she was found. So that means our investigation needs to start here, even if there's no missing persons report. And why would we not have a missing persons report? Who could this person be? Foster child. She could be a foster child. She could be a runaway. She could be somebody who had no family. Nobody to give a missing persons report. People are, we exist that way.
Maybe their family died.
Maybe their family died, absolutely, exactly, right? Let's look at this a little bit closer. Now, let's look at the green, okay? The places where this person was sort of in the recent past. I'm gonna, again, put some highlights here so you could see. I've circled for you all the places where the yellow overlaps with green, because those are places of interest as possibilities for this person being there, right, in the recent past. Okay? Now, I give this information to law enforcement. The first thing I say is, look, we gotta look here in Champaign County for this girl. Her family's not reporting her missing, but we start here first. And you go to the school. You go to the school and you look for a school record from everybody from 1994, before, and we see if we can find somebody. And then we figure out somebody who was a foster kid, somebody who didn't have family, somebody who was a runaway, somebody who would fit this profile. This sex, this age, this ancestry, etc. We ID'd her. Her family, her parents, still lived in Champaign County, and to this day they had never made a missing persons report. She had been a teenage runaway, and at the age of 16, I cannot make this up, she joined the circus. Hold on, let me go back, just so you can see. She joined a circus that traveled the Midwest and Southeast, from Wichita, Kansas, all the way down to North Carolina. And she stayed a good amount of time with a fellow carny near Little Rock, Arkansas, which is right here. So her name was Carrie Lynn Wyatt, And we made a DNA comparison. She had had a son, a little son, and she came back to Champaign County to visit her son. And through the DNA comparison with her son, we were able to identify her definitively. Okay, really quickly, because we are running out of time, let me go into our second case. This is a little bit shorter. So the first case, I didn't do all the forensic anthropology. I got called, I did one thing for the case, I worked with the investigators, we made an ID. This case was a case that we exhumed through our Central California Missing and Unidentified project. This is a Jane Doe who was found murdered in a rural area in Madera County, strangled, naked, out in an agricultural dump site. There is a place in Madera County where we have a lot of Jane Does that have been found over time, and a lot of them have ligature. We did the exhumation, we did the forensic anthropology on her. I estimated her to be between 21 and 24 years of age. And when I did the ancestry assessment, I had a pause. Because I was looking at non-metric, so that's the architecture of her body, the architecture of her skull, and then metric, which is the measurement of her skull. And I was getting a picture of this woman that she was Hispanic. I don't like that word, but that's the word that is being used from the measurement, but that the morphology or the architecture was coming up as indigenous. And this made me very worried because for forensic genetic genealogy, those two populations are not people who we identify because they are not in the databases that we use to compare unidentifieds to. So anybody in here who has done 23andMe or Ancestry.com, raise your hand. Okay, so if you didn't read the fine print, what happened is they took your sample and they populated it into something called GEDmatch. And GEDmatch is the way that we take either perpetrator DNA from a crime scene or unidentified DNA. And when we want to do forensic genetic genealogy, we do a whole genome sequence, every single chromosome, and we compare it to GEDmatch. So we're comparing it to you, all those of you who raised your hand. And those of you who are in that database more than others are white and black. You are not Native American and you are not Latino. And that is a problem. And I knew it was going to be a problem for me here with our Jane. And so right then and there, I called up the law enforcement and I said, you know, we're dealing probably with Latino or indigenous. See if there's other databases we can use, compare her to. And so when we ran her DNA, we got no hits on CODIS. But one of the death investigators in Madera ran her DNA against a private database. A lot of tribal nations now are establishing their own databases because of the missing and murdered Native American women and girls and Two-Spirit people. These are private. You have to know about them to compare your DNA to them. They're not public for anybody to use. Through that analysis, we got a hit. And that's how we identified her. Her name was Christine Lester. She was a citizen of the Navajo Nation. On the Navajo Nation in the 80s, hitchhiking was common because the Navajo Nation is very, very large and extremely rural. She was home from nursing school for Mother's Day, and she wanted to go get her mom a present in town. So she hitchhiked into town and got picked up by someone who drove her to Madera County and killed her and left her out in the middle of nowhere. She laid in the ground since 1987. We didn't pick her on purpose, it was random. Sometimes all you need to do is just put in the effort to make an identification. Everybody deserves to be identified. And sometimes all you need to do is just start. I didn't do isotopes on her. We didn't do facial reconstruction. We just did the bare minimum. And we were able to make an ID. I learned a lot from Christine Lester because I'm really focused on my work. And when we made this ID, we were so happy, right? Me and the death investigator and all the deputies who worked on this, we were like, whoa, this is amazing, right? We identified Christine, we repatriated her to her family, and when we got there, when the deputies got there, her family that was still alive didn't believe it was her. And her brother said to the deputy that it's not my sister, because she would have come to me in a dream and told me that she was dead. And so, you know, it was very humbling. And I'm sharing this story with you because I think a lot of people who are interested in forensic science, we focus on our own type of success, right? What, you know, oh my gosh, I made this identification. Oh man, I feel so great about it. I can't wait to give Christine back to her family and have her rest in her own ground. But you don't always think about what other people think or how they want that to be communicated to them, right? Or are you prepared to actually give that kind of information in a scenario like that? And so I'm sharing it with you. So if you do end up doing this kind of work, now you know. That might be your job someday. And it is great to make an identification, but there are other parts that are really important too, that matter. And her room was still exactly as it was, you know, the day that she disappeared, right? Over 35 years, somebody's keeping their room for somebody. It never occurred to me that that would be something that they would do, right? So anyway, that's it. That's all I have. Thank you so much for listening. If you have any questions, there's my email.
That might be working. Hello, yes. So we have a fun little ball. That's also a mic. I know this was such a fascinating talk. I'm sure there's some questions, but I also know that some people might need to get moving. So we're going to take a couple of minutes. If you need to go, please get up and go, and then we can have a nice quieter event while we have the Q&A.
We've learned that, especially high school students who come from extra credit, they'll just get up and go, and you're like,
Yeah.